So, a couple of things. I'm going to be trying live streaming to Twitch and editing for YouTube. I've been getting comments in the video for the last 2 years now saying, can you please make this stuff shorter? So I'm going to try live streaming to Twitch, where people seem to like the long form content and the interaction, and editing that out into shorter videos for YouTube. Let me know in the comments if that's something you like, or if you would prefer that I dual stream and keep the long stuff. So it appears that I have no green light on the charger. So as you can see, no green light. Now, the first thing I'm going to do is go over what it is that would cause you to have no green light on this particular board. But before I go over what would cause you to have no green light on this particular one, I'd like to show you what would cause you to have no green light on an older one, because it's only on the older schematics that this stuff is made obvious. So this here is an older machine that I'm going to show you. Now, this is the one-wire circuit. The one-wire circuit is responsible for allowing the charger, which it connects over here, so J6900 is the charging port, to attach to the SMC. So you have 18 volts, which is power, ground, which is ground, which you need to complete the circuit, and then SIG, signal. And on SIG, it says adapter sense. Adapter sense, meaning sense the adapter, means sense that the charger is there, talk to it, and then turn on. You have this chip, U6900. U6900 is what's going to allow the charger, which is external, to talk to the SMC inside the machine, internal, on the sys one-wire line. And as you can see here, it talks directly to the SMC. Bi means bidirectional data lines. Some stuff is input, some is output. BI means bidirectional data line, meaning that the SMC will talk to the charger, but the charger will also talk to the SMC. This is the SMC, and as always, this is Apple's little notification telling me that they want me to show you how to fix their motherboards. So let's just go back up here. Now, what do you think is going to turn this on? U6900 is going to be turned on if it has power at its VCC pin. And U6901 is what brings power to the VCC pin of U6900. This turns on if it has, this logic gate turns on if it has SMC, BCACOK on A and B, then it will shoot out power on Y. But to do so, it needs PP3V42. That is the 3.42 volt power line required for this to work. Now on the older machine, it's a little easier, right? Now watch what happens when we switch over to the Air. This is the schematic for the motherboard. Sys one wire just goes over to this thing called J9500. So let's just open up the schematic for this one. And check that out. J9500, which is just a cable that goes over to the DCN board. There is no U6901. SMC BCACOK goes into the DCN board, Sys one wire goes to the DCN board, and PP3V42 goes to the DCN board. But we don't get to see what's actually doing any of the work. So let me just show you what U6900 and U6901 would have looked like on an older motherboard, and then we're going to look at the DCN board, and you're going to tell me if you notice anything similar. So let's go over here into the microscope camera, and I'm just going to, so this is going to be U69. This is U6901 right here. You'll see that this is U6900. Now, let's take a look at the DCN board of the MacBook Air, because do keep in mind, the MacBook Air, they give me a schematic for the motherboard, but they don't give me a schematic for the DCN board. So, check. Now, tell me if you see anything on the DCN board that looks familiar. Anything look familiar? It's the exact same circuit, except what they do is they place it on the DCN board. So the same principle applies, and I don't want you to be scared of the one-wire circuit on the MacBook Air just because it's not listed in the schematic. It's the same one-wire circuit that you've been used to all these years in the old unibody MacBook Pros. Nothing has changed. All they did is they moved it over to the DCN board so that you can't really see much. So a couple of the things that you'll usually want to connect, that you usually want to check out, is corrosion by this connector, because if the PP3V42 via or the pads and whatnot over here are all destroyed, you're not going to get 3.42 volts on your DCN board, which means that the one-wire circuit is not going to turn on. You also need PP3V42 to be present on the board. If PP3V42 is not present on the board, then you're never going to get any satisfaction. So let's check out whether we have PP3V42 located on this motherboard, and let's go over what it is this other store missed. One of the lovely wholesale clients that we have here that only sends us stuff after they have tried to fix it and failed. Yep. Feels good. Feels good getting somebody else's garbage. All right. So, PP3V42 circuit on this board. Let's find that. All right. So, PP3V42 _G3 hot. to my... By the way, a lot of people have asked, how do you know what to look for when you search around the schematic? I'm looking for where PP3V42 is created. Here, PP3V42 is powering something. See, it's going into the VDD pin. That's not where it's being created. Here, PP3V42 is powering this chip. It's going into this VCC pin. VCC, VDD, in all that kind of stuff is pretty much where power is going to the chip to let it turn on. So for example, this is my microscope camera, this is my adapter to power it. I could call that the VCC or the VDD pin. It's pretty much where power is going in to power the thing. This is where PP3V42 is going to the trackpad connector, so that's not interesting to me. And as you can see, as I scroll on, PP3V42 is going to V in, so that's not it. Again, I'm not looking for PP3V42 powering something, I'm looking for where it's created. So I just continue to scroll past all this junk. And here we go. Now, voltage out, PP3V42. And now I know that I'm where I need to be. 3.42 volt power supply. This is where I need to be. So let's check out this area on the schematic. So U7090, and I can check the output of PP3V42 on L6095. So let's take a look at the U7090 area. U7090. So let's take a look at that area on the motherboard and see what we get. Not pretty. I don't know about you, but that does not look pretty. Alright, so we have C7080. I'm not sure if that's supposed to be there. So first things first is sometimes the schematic says that there are components that are supposed to be there that are not actually getting used for anything. So I like to look at a donor board just so that I can get an idea of what I should expect to be there and what shouldn't be there. So I'm going to grab myself a donor board. This resistor doesn't look good at the top. That does not look good. That capacitor looks destroyed. And over here, I'm not sure if there were supposed to be components here, or maybe there are, maybe there weren't, maybe they were scratched off by somebody's toothbrush. And you can also see that there's some oxidation that's scraping off over here. Let's clean this up a little bit. Let's clean up this area and make this great again. Just scrape away oxidation, scrape without ripping the pad off. It's never the coil, but come on. That coil looked like crap. So, we're going to get rid of that one. Alright, so now I'm just going to add some solder here to these pads, and I'm also going to try and scrape away some of the rust. I want the rusty looking junk to get sucked up into my solder ball. YouTube is cancer these days, they're screwing up everything, someone said. Alright. So I'm going to add leaded solder to all this stuff over here. And the whole idea behind adding the leaded is that it'll make it easier to wick. And what the hell, let's get rid of all this junk. I don't trust any of this. Okay, now I'm going to grab some wick. Whoops. Can you tell that I suck at content creation? Content creation is not my thing. Let's clean this up, make it look nice. Alright, now let's make these pads look nice again. See, anytime I see something that looks a little corroded or black, or you know, that nasty dark silver in color, I give it a little bit of gentle scraping. Just a little bit of gentle scraping. Alright, so there was indeed a resistor missing. So there was a resistor missing. When I look at all of my donors that I have here, there was one that was scraped off. And that most likely did not occur during the original corrosion. That occurred when somebody tried to clean it with a toothbrush. And it was this resistor right here. So let's look up what that resistor does before I go and fully attach it properly, shall we? Let's check out what that's for. Now, if you look on the schematic over here, that is R7080. So let's look up what R7080 does. R7080 is the resistor that takes the input voltage and brings it to the SHDN pin. So let's figure out what the SHDN pin does and see why that resistor might be important. So what does the SHDN pin do? That's pin 8. Now, and most of the time in these data sheets, you're going to see a lot of information that you're not really going to be able to make heads or tails of. Honestly, all I care about is chip function. And it's usually called pin function or something like that. So it says the shutdown pin is used to put the LT3470 in shutdown mode. Tie to ground to shut down the chip. Apply 2 volts or more for normal operation. So if the shutdown feature is not used, tie this pin to the VN pin. So apply 2 volts or more for normal operation. Now let's go back to our schematic over here. So how are we getting 2 volts to this chip? Well, here is the input of the chip, pin 6. And what the R7080 does is it ties the input voltage to the shutdown pin. So this chip can be powered either off of the battery, or if the battery is dead, it can be powered off of the charger, which is right up here. So this chip is going to have an input of either 8 volts or 16 volts, either of which are going to be high enough to get the chip started. However, if R7080 is missing, then instead of having 8 or 16 volts on this pin, you'll have 0, and 0 volts will shut the chip down. So there's a very good chance that the original chip was good. I still didn't want to leave it on the board just because I know corrosion got in that area. It would be really poor practice to leave something that's clearly corroded or clearly around corrosion on the board. I don't like to do that. So I took it off, and we're just going to repeal and replace the entire PP3V42 circuit just to be safe. Now you'll notice that some of this soldering is not great. You'll notice with a lot of my videos that that's not great. But what I'm trying to do here is not get perfect soldering on the first time. See, this flux is going to expire the more I heat it. So what I'm interested in doing is just barely getting the chip on the board, and then at the end, I'm going to reflow everything into place. I don't want to use excessive heat on the board while I'm working on it. So I used a bare minimum heat just to get the chip on there, just to get the component on there, and at the end, I'll flow everything into place at once, rather than heating every single chip every single time. So see, that's not properly soldered, but I'm okay with that because I don't want to, see right now, even though I'm heating this bottom capacitor, I'm technically also heating the top one. So whatever component was put on first is going to see a lot of heat if I continue heating the same area, and the way that I seek to avoid that is by just barely using enough heat to place it on the board, and then at the end, I'm going to flow everything into place. And you'll see. And these are all things that you're going to have in the back of your minds. I know right now it probably seems like a lot of this stuff is overwhelming, too much information. But once you've been doing this for a while, this is going to be instinctual. You're not going to have to think about it, which is where I am right now. And it's just going to be part of your strategy of, just treating the boards nicely, and so that they last longer, so that your repairs have less warranty, less chance of coming back. Eating Monica, sure. Okay, so see how everything flowed into place there? See how everything flowed into place there? So now I'm just gonna wait for my iron to heat up. Do this. Beautiful, beautiful, beautiful. Get rid of any excess there. Ah, this is looking great. Absolutely beautiful. Everything in its right place, as Radiohead would have said. Okay. Now we're going to cool this area of the board off just a little bit, and after we cool it off, we're going to see if it turns on again now that we got PP3V42. Now, we may have to go over a couple of other areas if there's any more corrosion. We're going to look for it and see what we have. Okay. Alrighty. Alcohol the board up. So now we're going to see what we get if it's plugged in. Now, when I plug it in, I still get no light in the charger. As you can see, the light is not there on the charger. So, however, as I said, the one-wire circuit is located on the DC inboard, which means PP3V42 needs to make its way over to the DC inboard, which means that we have to make sure that those pins on this connector are not corroded. We have to make sure the pins on this connector are not... And hey, what do you know? What's this? What's this? Ooh, that does not look good at all. I think that's a hint. That is a great hint that we need to fix something else. So let's... First thing I'm going to do here is I'm going to try and scrape some of that oxidation off the pin, and then I'm going to scrape away some of the insulation over this trace, and then I'm going to run a jumper wire from the trace to the pin. So let's get to work. Let's move move the microscope into a position that's a little bit more comfortable. Just feel free to make yourself more comfortable. All right. While I scrape your traces away. And look, the pad is actually there. Under the oxidation, there is actually a pad there. Check it out. See? However, that pin may not be anywhere to... Yeah. Where's my pin? Where'd you go? Okay, let's get that pin. Okay, now this is going to be the fun part. Soldering the pin. So I'm going to give it a try with the T15 JSO2 tip on the 2027 iron, which is the larger iron. We'll see if this works, and if this can't do it, then we'll try the micro one. But I think I may have a chance of actually getting this done with this one. I may have to do a little bit of cleanup because this tip is a little too big. Alright. This tip is a little too big for the job. Said none of my dates ever. So we're just going to wick the solder that I got on the ground of the connector over there, because that's not right. There. This tip is a little too large, so it's touching both the side of the connector and the pin on the board. Alright, I'm happy with that. I managed to scrape away all the corrosion on the pin and also on the pad, cleaned it up, added some flux, and made a nice new solder joint. Alright, got my battery wire. Might as well tin it a little. Now keep in mind, wick is nothing but wire. It's just a bunch of thin wires together. So a single strand of wire is actually going to suck up the solder that you put on your joint. So you're going to have a little bit of solder on your iron. And a little bit of solder on, and then a little bit of flux on the place where you want the joint to be. And you're going to place it there because the wire is actually going to suck up your solder. This isn't straight. Come on. There we go. Okay. So, do that. Beautiful. Okay. Plug in the charger. And hey, we got a light. Check it out. Isn't that amazing? We got a light, and we've got a fan spinning, which is beautiful. Now, somebody also mentioned that the JTAG connector looks terrible, so we're going to end this repair by murdering the JTAG connector. Ha-ha. We're going to end this repair by destroying JTAG. JTAG, say goodnight. Say goodnight, you mother. Yes. Let the Genius Bar try to diagnose you now. Let Apple's internal refurbishing plans try to diagnose you quickly now. Oh, what? When you're refurbishing it, you want to flash the SMC without reballing it? Oh, you want to program the BIOS without desoldering it? Oh, yeah, me too. Me too. How do you feel about that, Apple? How do you like them apples? No pun intended. How do you like? Yep. Yeah, my motto is if they're not going to give me simple repairs, then hell if I'm leaving any for them. You want to reprogram this SMC when it goes back to you? By all means, have fun removing it from the board, programming it, reballing it, putting it back on. Just like everybody else. That's what we call equality. That's what we call equality. All right. So this board is good to go. It just has to go through the ultrasonic cleaning process. After it's been ultrasonically cleaned, we can then say that it's good. But yeah. So as you can see, there's really not much to fear about the one-wire circuit on the newer Airs. Yeah, it's a different failure mode than before, but it's all the same chipsets. There's nothing really crazy about it, nothing that's overly confusing. You know, it takes a little bit more skill to run the jumper wires than it did on the 820-2530s and the 820-2879s that always had that issue with U6901 being right on the corner of the board next to the LCD connector and corroding. So again, it's going to require you do a little bit more work, but it's It's not that bad. It's not that scary.